look at the geometry of iterated integral. So iterated integral, we have like two layers of functions, and we usually have a function f of xy as my integrand. But f of xy can be a constant function. Let's say f is equal to 1. Okay? So that's a special case. I don't want to have a complicated integrand. I just want to have 1. When f is equal to 1, when the integrand is equal to 1, we can either write it out or we just leave it as is. So when you see this notation, or when you see like a, b, and then dx, this really just means you integrate 1 with respect to x. So same idea here. All right. So now with this special case, we can sort of really focus on the two integrals that we have. Okay, so these two integrals together, they determine the region of integration. I'll tell you what it means. Okay, so from inside, I can see the lower bound of y is equal to 1 and the upper bound of y is equal to x, right? That's how we read it when we write the lower limit and upper limit in an integral. Even though this is a iterated integral, we still read it the same way. Okay. Similarly, for the outer integral, we have, x bounded between 1 and 2. Okay, lower limit is 1, upper limit is 2. These two together determines a region. Okay, let me show you. So I have x direction, I have y direction. So if I say y is from A to B, what does that mean? That means I have a line y equal to A, I have a line y equal to B, and I'm looking for things in between. From A to B, then I stop. Okay? And it's the same idea when I have something that's a little more complicated. So I can have two curves, y equal to g2 of x. Okay, so that's something. I can have y equal to g1 of x, and that's something. Okay, and again, I want y from g1 to g2. So I'm only looking at things in between. Okay, so that's what we have by saying y bounded from g1 of x to g2 of x. So for different x value, you are gonna have a different lower bound for y and different upper bound for y. So like that. Okay. Now let's look at what we have here. So we have a relatively simple case. Let me not erase this. Let me keep that. So the lower bound is y equal to 1. The upper bound is y equal to x. So I have y from 1 to the point when you hit this curve y equal to x. Okay? For each x, the lower bound of y is 1, the upper bound of y is this curve y equal to g2 of x. This is our g2 of x. Okay? All right. So we're looking at things from 1 to this curve. It's even though it's a line, but in general we can say it's a curve. Okay? But we only want to focus on the part where x is equal to 1 and x is equal to 2. Okay? So let's find where it is on the graph, x equal to 1. So when x equal to 1, it happens to also pass this point, because this is point 1, 1. Okay? So this for this point the y coordinate is 1, so it lies on this horizontal line, and because it's 1, 1, x is equal to y, so it also sits on this diagonal line. Okay, so for x, for the x value, I don't want anything that's smaller than 1. I only want stuff that's larger than or equal to 1. And then I'm gonna stop at x equal to 2. Okay? So if I look at the intersection of this stripe and this area of the triangle from 1 for y from 1 to y equal to x, you can see that this is the area we're looking at. Okay? So when I have an iterated integral, by reading the integrals, I'm able to sketch the region of integration. So we're integrating the integrand over this region. All right?